Hey guys, this is the Chapter 5, Lesson 3 packet. I'm going to help you get started on this. I have a meeting today, so I can't be in class, but I wanted to make sure you had a good start on this material, good jump on it, because we're going to spend 2 classes on it. So first, what I'd like you to do, skip number 1. We'll do these free throw shooting predictions with me when I come back to class, just about probability, and then scroll down to number 2, homeowners in high school. We saw this in the previous packet. We're going to be using this table again. Now, for noting a conditional probability, that means the probability of one event given that another event has occurred. If, for example, we want to know the probability that you're not a high school grad given you're not a homeowner, I would say, okay, we're given that you're not a homeowner, so cover up this entire row and cover up this row, and you'll know you're just looking at not a homeowner, since that's the probability that you're given. So if you're given the probability of A given B, that means event B has already occurred. What's the probability of A? So if that's the case and you're looking at a table, cover up all events that don't include event B, which has already occurred. So in this case, we were saying probability that you're not a high school grad, given that you're not a homeowner. Given that you're not a homeowner means not a homeowner has already occurred. So you'd cover up this row, cover up this row, and you'd look at 71 out of 160 as your probability. So that's the tip that's mentioned right up here. So just review that. Okay, so what I'd like you to do is go ahead and start on A, B, and C, and pause the video. Work on A, B, and C on your own with your group, and then go ahead and check the answers here. So start with A, B, and C. So here is the solution for A. This is the probability of A given B. So if we know a person owns a home, that means B, given that they own a home. Remember, this vertical line means given. So we know that they're given that they own a home, so you should cover up the second and third rows and just be looking at this top row. And we want to know the probability that they're a high school graduate. So we look at 221 out of 340. Now we were given that they own a home, remember, so we'd cover up not a homeowner and cover up the total, and then that would lead us to the answer we have. When you write your answers, please express them as fractions and decimals. Okay? The fraction, don't need to reduce it because this lets us know 221 out of 340. Now, if we did the probability that, if we know that they're a high school graduate, what's the probability that they own a home? We know they're a high school graduate, so we'd cover up the second column and the third column. We're just looking in this first column. 221 are homeowners out of 310. So 221 over 310. So remember, if you're given that another event already occurred, that means we're saying what's the probability of an event given that this event occurred, so we'd cover up these other columns so we don't get confused. Okay, go on to C and pause the video until you're done. Okay, so when we look at this two-way table, we see the probability of being a homeowner does not equal the probability of being a homeowner given that you're a high school graduate. So the two events are not independent. We can't be sure if there's an association from this data. So remember, for probabilities, for two events to be independent, then this has to be true. The probability of an event has to equal its probability given that another event occurred. So the probability that event A occurs should be the same as the probability that event A occurs given that B has occurred. This just means that B happening doesn't change the probability that A happens. That's the definition of independence. This event B does not change the likelihood that event A is going to happen. So this is true in flipping a coin. If we look at A being heads and B being tails, what's the probability of a heads? It's 1 over 2, or 0.5. What's the probability of a heads given that you've already flipped a tails? It's still 0.5, it's 1 out of 2, because successive flips are independent. Tails on the last flip doesn't mean I'm any more or less likely to get a heads on the next flip. So that's the definition of independence. A second event happening doesn't affect the first event. So if events A and B are independent, this is true. And what else is true is also that A occurring doesn't affect the likelihood that B would occur. In D, we're checking to see if they're independent. So the probability of being a homeowner is 340 out of 500. The probability of being a homeowner given that you're a high school graduate is 221 out of 310. Here this equals 0.68. That does not equal 0.7129. So by our definition up here of independence, the two events are not independent. Okay, go on to number 3. Pause the video here. You should be turning to page 314 to check your understanding. Complete that and then check your answer here. So, the probability in 1 they're talking about of grades that are lower than a B. So we know 3,656 out of 10,000 satisfy that, which equals 36.56%. Now, the probability of being an engineering student, given that a grade is below a B. Remember, given that event L has occurred, cover up all columns or rows that don't include event L. See what's left. Well, E occurring, given that L has occurred, is 800 out of the total of 3,656. That's the number we had up here, the total that had grades lower than a B. 800 from, I think this is engineering and science classes. Now the probability of L, the probability of a B, grade lower than a B, given that they're engineering, would be 800 out of 1,600. Since we're given that E occurred, that they're engineering science student, cover up everything that's not included in event E, we have a total of 1,600, and 800 of those satisfy event L. So that's the probability of getting a lower grade if the student is an engineer. So we covered up everything that wasn't engineering. And we'd want to compare that to the probability of getting a lower grade if the student was in liberal arts and social sciences. Okay, please go on to number 4, allergies. So we're looking at a relationship between gender and having allergies. So here's a table. It's an SRS of 40 students from the US Census. Okay, so use what we just went over to determine if the events female and allergies are independent. So if they're independent, then knowing the gender wouldn't affect the probability the student has allergies. So the probability of allergies should equal the probability of what? Pause right here and answer A. Well, if they're independent, then the probability of allergies would equal the probability of allergies given you're female. So probability of allergies given you're female is 10 out of 23, which equals 0.435. Probability of allergies is 18 over 40, which is 0.45. So these events are not independent since those two numbers aren't equal. Now they're not very different, those two numbers. So we would also say that there may not be an association between the two. And that kind of leads us into B here. So this was an SRS of 40. So what that means is that by chance, we might have just gotten different numbers here. These two events may be independent. And by chance, we might have just gotten more males with allergies. Or more females with allergies than there really are. So perhaps just by chance variation, if we did another SRS of 40, we may get different results. We may get that the two events are independent. By chance, too, with another SRS, we may get that more females had allergies than males, whereas in this case we had more males with allergies than females by percent. So due to chance variation in our small sample size, our results may not reflect the actual probability. Remember that probability is an estimate of the likelihood of an outcome, but just by chance variation, we're going to tend to have numbers that are different. Just like if we flip a coin 100 times, we're not going to get 50 heads every single time we do 100 flips. By chance, we might get 48. By chance, we might get 55. Now, if we got 95 heads, we would doubt that happened. That is not a likely occurrence given that the probability is 50%. So these should be close, but if we did another SRS, we may have different results. If we had a larger sample size, we would tend to have more accurate results. Okay, so now what I'd like you to do in number 5, flip to number 5 and draw a tree diagram representing these possible outcomes. Now a tree diagram is going to start with the chance event. So your tree diagram is going to be the probability of picking a sneezer. So flip to number 5 here. Start with your first chance occurrence, picking a sneezer. Now we're choosing 2 students. So there should be branches going and then a second chance event of picking a sneezer. And along each branch, label the probability of that occurring. Now keep in mind here, if we choose a student, we can't choose them again. How is that going to alter your probability? Or is choosing the first and second sneezer going to be independent events if they're not replaced, or are they going to be not independent? Okay, refer to that table that you have from the previous question and go ahead and solve your tree diagram here. Okay, let's look at what your tree diagram should look like. If we randomly select a student, 18 out of the 40 have allergies. So there's an 18 out of 40 chance that we pick a sneezer, somebody with allergies. 22 out of 40 don't have allergies. So there's 22 over 40 chance that we don't get allergies. So these are our first student's possibilities. Allergies or no allergies. Now, this is the interesting part. Because there's no replacement here, because a student can't get picked twice, these probabilities differ depending on the outcome of the first event. So these are not independent events because the probabilities change. So the probability of picking a second student depends on the probability, depends on whether we picked one with allergies or no allergies on the first. So if we picked somebody with allergies, there's one less student and one less person with allergies. So picking a second person, the chances of picking that second person are 17 out of 39. Now, given that we've picked somebody with allergies, the chances of picking somebody without allergies is 22 out of 39 because we removed one person from the total pool to make 40 and 39, but we still have 22 people that don't have allergies. So if I were to follow this branch of the tree, 18 over 40 times 17 over 39 would give me the probability of picking 2 sneezers. Let's look at what that is. So the probability of a first student with allergies and a second is 18 over 40. The probability the first one gets picked times 17 over 39, which equals 0.196. Let's look at our other possible outcomes. So we could pick a student with allergies and then the second student with no allergies. That'd be 18 over 40, just following the branch here, times 22 over 39, which equals 0.254, about a 25% chance of that happening. Now, if we pick the first student with no allergies, there's a 22 over 40 chance of that happening. Given that we've picked that student, there are now 39 students left and 18 of them have allergies. So there's an 18 over 39 chance of picking somebody with allergies on the second student if the first student didn't have allergies. Now, the probability of picking a second person with no allergies, now we picked the first with no allergies, so there's one less person, so 40 in the denominator becomes 39. And there's one less person without allergies, so 22 becomes 21 because there's 39 students left and now only 21 of them have no allergies. So then here we list our possible outcomes. There's a 24% chance of no allergies, allergies, and then there's a 31% chance of no allergies, no allergies. Now, think to yourself, what must be true about adding these 4 probabilities if they represent all possible outcomes in our sample space? What should they sum to? Well, when you add them all up, they equal 1 because they represent 100% of the probabilities. One of these 4 outcomes would always occur. So this tree diagram is going to be a very useful and crucial tool to use whenever looking at probability. It makes things much easier and it's a way of organizing your thoughts. Okay, please go on to, and both students suffering from allergies, follow branch 1, allergy, 18 over 40, that's where this number comes from, 17 over 39, and we multiply it to find the likelihood that both events occur. Okay, go on to this check your understanding on page 317. I'd like you to work with your group. Pause the video now. Once you're done, please check your work. Okay, for 1, you should have gotten independent. The probability of a heart and conditional probability are equal when you replace the card and reshuffle. So as long as we put the card back in there, the 2 events are independent. Now, if we didn't replace the card without replacement, then they wouldn't be. For number 2, you should have gotten not independent. Turning over heart on the first turn would change the probability of doing so on the second. Okay, review those answers and then finish 3. Pause here. You should have gotten independent. Once we know that the chosen person is female, this does not tell us anything more about whether she is right-handed or not. Overall, 24 out of 28, 6 out of the 7 students are right-handed. And among the women, 18 out of 21, which is 6 out of 7 are right-handed. So the probability of being right-handed and the probability of being right-handed given that you're female are equal. So those 2 events are independent. Okay, guys, please review any answers you need to from this packet. Go on to the homework questions, which are posted in Schoology, and they're also at the beginning and the end of your packet. So go do, it's a little more than the first half, and be sure to let me know at the beginning of next class if you have any questions. Make sure you also get your project back, your project rubric for chapter 3. You have 1 week to make any corrections you'd like and come see me outside of class for help and to show me any work that you've done on it. Make sure you come see me with any of those. You have 1 week, so that's next Wednesday.